So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So my name is Neeraj Kheria, and I have been working in this IT industry for close to 12 years now. All right, so the main agenda for today's session is we will be discussing on the entire concept for AWS first, the entire introduction to AWS. Then we will be discussing on what exactly is containerization tools and how the entire concept for Amazon EKS as in Elastic Kubernetes Service works and how we can launch the app on the EKS platform. That is our main agenda for our session today that we are going to discuss step by step. Now, AWS, as we know, is the global leader in terms of cloud computing services. So AWS is having always had and currently still it holds the biggest market share in terms of cloud computing. So currently it has almost 32% of market share, then followed by Microsoft Azure, having a market share of around 18 to 19%, and then followed by GCP, having a market share of around 11%. And then we have multiple other vendors like we have DigitalOcean, we have IBM, we have VMware, we have Alibaba Cloud Services as well. So there are multiple vendors that we have in terms of Amazon Web Services, right? And these all are different cloud platforms. And AWS, as we know, is a collection of more than 150 plus services. AWS has a collection of more than 150 plus services that we can go ahead and deploy our applications on. So when we talk about 150 plus services, that includes services for computation, for storage, for networking, for IoT, for AR, VR. So there are multiple services on which we can deploy it. All the major companies, they all are customers for AWS, be it Hindustan Unilever, be it Netflix, BMW, Adobe. So they have a long list of clients, those who all have deployed the services on top of Amazon Web Services itself. And they are different domains now. As we had discussed, there are 150 plus services currently offered in AWS. To be precise, it is 157. And it offers services on computation, on migration, security, storage, networking, content delivery, messaging, databases, and management tools. And for getting a detailed view here, so we can simply open up this link called aws.amazon.com. We can see the entire list of all the services that AWS has to offer to us. So based on computation, integration, cost management, on blockchain, on containers, on end-user computing, on media services, on IoT, on databases. There are multiple applications on top of which we can deploy these services or deploy our application here. And then why AWS is such a hit? Because of multiple reasons. Because again, AWS has, first of all, a large collection of different services based on different categories, right? For example, let's suppose if we talk about the computation, then we have the service called as Amazon EC2, where EC2 is cloud computation service. Then we have Lambda as a part of serverless computing. So EC2 is based on the virtual servers, whereas Lambda is based on serverless computing. Then we have ECS as Elastic Container Service, offered as a service on where it is mostly used as a DevOps tool when we are working on the entire AWS platforms. And then we have Kubernetes. So Kubernetes, as we know, it's an open source container management tool, which is basically used for automation, for automating the container deployment, and then descaling and upscale. We can simply scale it up and we can also take care of the entire load balancing as well. We can take care of load balancing as well. And basically, Kubernetes, as we know, is one of the most popular container management, or we can say orchestration tool, where if we have a large cluster of containers, that we had deployed, then we also have Docker Swarm, right? But again, Docker Swarm is efficient for small scale application. If we have large number of containers, then Docker Swarm fails, and that's where Kubernetes come into play. As a part of entire setup here. Now, the features, if we talk about the main features of Kubernetes, offers us an automatic bin packing. So now we know that we have the entire, when you talk about containers, containers, they contain the application and all the bins and libraries for that, right? So the application, so any container, they package two things here. They package the application, right? And they also package the entire bins and libraries required for running that particular application as a part of entire container, right? So the entire bin packing is automatically taken care by tools like we have Kubernetes, right? And the entire service discovery and load balancing, that means the traffic If we have too much of traffic and then we want to distribute the traffic among different containers, then that can be done easily by using Kubernetes. Storage orchestration, as in if we are looking to distribute the storage services, just like we have HDFS where we can distribute the entire storage. Suppose that if we want to distribute the entire thing based on different networks, right? Based on different networks, based on different nodes, then we can easily do that, right? Same thing is also applicable. Same thing is also applicable on top of Kubernetes. And Java 1.3 is offered as a part of self-healing. Then it also offers a secret and configuration management system. It offers us batch execution, horizontal scaling, and automatic rollbacks and rollouts. That is just like we have for Chef and Puppet, right? Where we can roll out and where we can roll back and rollouts easily for n number of containers. Same thing is also applicable for Kubernetes. If we talk about the entire concept for containers, now whenever we want to launch, whenever we want to share any application with the others. Now, for example, let's say we are looking for the application, right? We are looking for sharing any application. Let's understand this by a simple use case. What exactly is a concept for containers? Go to our Picasso mode. Now, let's suppose here we have coders, and then here we have operations team. And kindly excuse for this beautiful calligraphy, guys, because that's what happens when we try to write using the mouse pointers. If we have the coders and operations team, now the coders, they developed a code on top of Java 1.7. They have developed the code for a Java application, right? And they have developed this on suppose on 1.8. And now they, for testing purposes, they have sent this code to the operations team, right? And when the operations team, they try to run this entire Java code, the code did not work, right? So now they simply complain back to the code that their code is faulty, their code is filled with bugs, and that's why it is not working. Now the coding team checked again, and Java application code was working fine without having any kind of issues, right? So that means once again, when they send the code to operations team, still they were facing issues. Why? Because the operations team had the Java 1.6 version configured. So obviously, if we have a difference in version, then that will create a compatibility issues, right? And that's why we have to make sure we send the exact copy and as well as the environment if we want to maintain the consistency between the coding, that means the development and the operations team, right? So what we can do is there are two ways of doing this. We can either create the entire VM, as in we can create the entire VM image, as in virtual machine image, where we have to pack the entire operating system, the entire application, the entire data set, and then we can create the image out of it that we can pass this image to the operations team, and then operations team have to use this image to set up the server and then start deploying it. And again, since this entire VM contains the operating system, the applications, the data, and everything packed inside, that's why this will be much more heavier, because if a typical VM can be as less as 1 to 2 GB, right? So if we are continuously making changes, then that requires 1 or 2 GB of VM to be created and downloaded again from the operations department, right? So instead of doing this, instead of working on VM, what we can do, we can take the help of containers. We can take the help of containers as a part of a Docker environment. And these containers, they do not contain the entire operating system. They simply contain the application and all the bins and libraries that is part of dependency for the application. So that if the VM it is for 1 GB, then this will be simply like a small file of max to max up to 20 to 25 MB as well. So this thing simply makes the job much easier for the entire teams to collaborate with each other without worrying about sharing large containers, large virtual machine images. That's why we need to have containers here as a part of entire example. So the traditional VM, it contains the hypervisor, the server, the guest operating system, the bins, libraries, app1. So each VM has an application, necessary binaries, libraries, entire guest operating system. That's how we can simply deploy the entire application on top of it. Whereas in containers, as a part of the entire container, the containers, they contain only the app and the bins and libraries. They do not contain the guest operating system. Hypervisor, server host, these are already pre-configured in containers in the entire container environment. And in each and every individual container, we simply package the app, and all the built in libraries to support that. And a container it simply comprises just the application and its dependencies. Now let's talk about Docker and Kubernetes. So Docker is as we know, is the most popular application for the containerization. It's the most popular containerization tool available, where we can use it for building and deployment of containers. And how to coordinate and schedule multiple containers, and how do containers communicate, and how to scale container instances, how to deal with failed containers. For these parts, we do have to take care of a container management tool like we have Docker Swarm, right? So just like we have Docker Swarm, we also have Kubernetes. So Docker Swarm is ideal for small scale application where we don't have a large cluster of containers that we have to take care of. If it's a large cluster of containers, then that's where Kubernetes come into play. So Docker is a tool for creating the containers, and Kubernetes is a tool for managing those large number of containers that on which we had deployed the entire application on. And then we have the service named as Amazon Elastic Container Service, called as EKS, right? So Elastic Container Service, or called as EKS, is a fully managed service by AWS, which simply makes it easier for us to run Kubernetes on top of AWS without needing to stand up, or we can say maintain our own Kubernetes control plane. So unlike the conventional method, unlike the conventional requirement, there is no control plane required to manage, and it is secured by default. It is compatible with standard Kubernetes, and it works with Kubernetes community. It simply works with the entire community here as well. Now here we can get started with Amazon Elastic Container Service for Kubernetes. Now here, first of all, here we have to provision the Amazon EKS cluster. Then we can deploy the worker nodes as a part of CloudFormation template. And then we can connect to EKS using the kubectl. And then we can run Kubernetes application on the entire EKS cluster. We can do that. What is the advantage of EKS over the normal containers? So again, we cannot compare containers over the EKS. So containers are the containers in which we deploy the application, and Kubernetes is simply used for management of those containers. Just like we set up the Kubernetes on our on-premise servers, right? Same way we can use EKS as a fully managed service offered by AWS, on top of which we can deploy Kubernetes for management of our entire cluster of containers. EKS is a service for deployment of Kubernetes on top of AWS. EKS is chargeable. So not all services are available under free tier, but again, EKS is chargeable. So now let's see how exactly to go around with this one and how to actually start deploying it. So now let's go back to our entire console. All right, so now here we can create the entire cluster here. Now for the implementation of EKS, let's log into the console. Here we can define the root username. Let's define the root username. Now for this, we do need the access to the entire AWS account. Here we can log into our console here. Now once we log into the console, first of all, we do need to have, now before we can start deploying the EKS here, we do need to have entire custom VPC created. And we also need to deploy the entire custom VPC along with the entire AWS CloudFormation as well. Because at the end, we will require to deploy the application on top of our own custom VPC. So now in here, we can define the role here. First of all, in order to get started, we have to define the role. So here we can come back to our service called as IAM. IAM is basically used for identity and access management service. So we can open up IAM, let it open up. May take a couple of seconds. It's taking a bit longer than usual. Now, once we are into IAM here, we have to define the roles here. We can open up roles. And then under roles here, we have to create one role for the EKS. So here we can simply click on create role. Here under the service here, we can choose EKS. So here we can choose EKS manage to, because here we have to allow EKS to manage clusters on our behalf. So here we have to define permissions. We can define add permissions. Here we also already have these two policies, EKS cluster policy and service policy. We can define tags, review, We can name this role as EKS review. Just a moment. Now, once we have the entire role created, now here we will be using this entire EKS review has been created that we'll be using here, right? Now, once we are done, next is we do have to have a custom VPC that we have to create. We do need to have a custom VPC that we do have to create here, right? So what we can do, we can use a custom stack template. So let's first of all fetch the entire VPC template in case there is no VPC created from your end. Just a moment. Now, in terms of VPC, we already have a custom VPC created. So for checking for that part, we can come back to VPC. And because again, as a part of our own cluster management, we do need to have a custom VPC deployed. So first of all, we have deployed the entire role, and then in VPC, we need to have a custom VPC deployed. Here we are using the default VPC that is available from our AWS. So let's change our region from North Virginia to Mumbai. And currently we can see we do have a custom VPC created that we will be using as a part of entire cluster management. Check for the roles as well, just a moment. Now, once we have the VPC and role created, now we can come back to our EKS cluster. So here we can, another service here, we can search for service name as EKS as Elastic Kubernetes Service. Let's open this up. And this is a dashboard for Elastic Kubernetes Service on top of Amazon EKS service here. And that's how here, now here we have Elastic Kubernetes as a service, which is a fully managed Kubernetes control plane service as a part of service offered by AWS. Now here we have to start by defining a cluster name. Let's suppose here we name it as EKS and review itself, just like the same role that we define here, or we can name it as EKS Edureka. So here we can define EKS Edureka, then we can simply define next step, and then we can define the Kubernetes version. So here we can define Kubernetes version. Which version are we to install here? So by default, it will be set to 1.14, and here we can keep it to 1.13 or 1.15. So by default, it is basically focused on 1.14. And then we can define the role name here, right? Because again, role has to be assigned, because until we have a role defined here, we won't be able to create that. We won't be able, now this entire cluster will not be created, right? So here we can define the entire VPC, that means the custom VPC that we may have created. So we can choose the default one, or we can choose the custom one as well. We can choose default or custom both. We can choose accordingly. So Dilip, so what is the difference between Kubernetes control plane and basic Kubernetes cluster? So it's like now, just like we have a dashboard, Dilip. Now in the default, we have to set up the dashboard, correct? So same way we'll be having the entire control plane with us. And then here we have VPC. So under VPC, we have VPC. In here, we can define the entire subnets one by one. And then we can define the security groups. Let me suppose here we can define in which particular zone and again in which particular subnet we are trying to deploy this one by one. What is a security group? What is the entire security group that we have on which we are looking to deploy us? Right. So here we have the entire security groups having the access to one specific protocol from which we can choose. Just like we have multiple services defined here, we can simply define this one by one. So now, once we have defined this, then we can we have to choose the network group in which we are given the access here, right? And then we can define the private access. If we want to keep it for private within a VPC, then we can define that. And then we can define the public access here by defining the enable. If we want this to be accessed outside our entire current VPC, then we can define the entire VPC endpoint there. And then we can define the entire encryption. If we're looking to encrypt this with our own KMS, then we can simply encrypt that as well. If we are looking to encrypt this with our own KMS, we can do that. And now once we define the entire cluster here, so now in here we can simply define the entire individual clusters one by one. So here we can simply click on create clusters. We can define the cluster templates if we want to start with entire cluster template based on networking only, or if we want to go for the AWS Fargate, we can simply create the entire cluster templates, and then we can start deploying the cluster, and then we can simply create the entire cluster so that we can start deploying the containers inside this cluster that we can, for which we have deployed on top of AWS. Whatever activity we can do on this console, the same activity can also be done on the entire concept of CLI as well. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.